T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
My name is Tatyana Ivanova, I'm 18 years old and I come from a small country in Europe called Bulgaria. I'm currently training to become an astronaut. I'm a drummer, a poetess and author of a poetry book. Actually, I'm writing my second one right now and I really hope to publish it this year. Students in Bulgaria usually start high school in 8th grade. That's why when I was in 7th grade, I decided to continue my further education studying English and Russian language in the foreign language high school. But when I was in my junior year of high school, last year, 2020, the pandemic, I decided to transfer to a private high school and my profile is information technology, math, English and Spanish. I think that's perfect because if you want to become an astronaut, you need to know at least 2 languages, to speak at least 2 languages fluently. And it's really an advantage that I'm right now studying 4 languages. I'm a scholar of the Education USA Opportunity Funds Bulgaria program. I'm actually preparing for America, for the United States, because I really want to pursue a degree in engineering. I want to become an aerospace engineer, and then I hope meteorologist or geologist, or study something about the rocket propulsion, rocket engines. That's why I applied to this program, and I'm very, very pleased that I received scholarships because that gave me the opportunity to apply to American universities. I'm also a scholar of a Bulgarian foundation called 100 Suns. I am a student space ambassador for the Mars Generation Foundation and I'm part of the outreach team of We Are Mars. I'm also the first president of Infinoscope Magazine and I also volunteer in many organizations just because I really love helping others. And I believe that my mission as a human being is to be a good person. As I mentioned before, I'm a drummer, a poetess, but I also danced for 10 years. And, I grew up as an extremely curious and artistic child. And I really wanted to find out how the whole world works and to try everything. I'm really glad that I finally found my thing, my passion for space part when I was 15. And I think my ultimate life goal is to become an astronaut and eventually be one of the crew on the mission to Mars. In this slide, you can see some of the photos that I really wanted to share with you. They're from my drumming performances, but I also represented Bulgaria in Tianjin, China. I was part of their Children's Culture and Art Festival. I danced there and it was pretty amazing. There are photos of the Bulgarian Red Cross on my book premiere, from interviews and camps, and me doing the split on the Great Wall of China. So when I was 15, I found out that there was a competition in Bulgaria and the prize was a full scholarship for the space camp in Izmir, Turkey. Turkey is very close to Bulgaria, so that was an amazing opportunity for me. And I actually applied 2 times and I won the scholarship on my second try. So never give up. While we were at space camp, we watched several movies that were provided by NASA to the camp, and one of the movie was with an astronaut on Europe, the moon of Jupiter. So the movie started with a quotation, imagine that this astronaut is you, and I don't know why, but something in my heart, exploded. That's why I did my best and I won the medal outstanding camper. It's a special individual award that is given to one of the campers. And during my way back home, I decided to create a plan or a strategy how to achieve my goal, how to find different opportunities. Just because I'm from a small town, and that's a big drawback, I decided to quit dancing and start physics lessons just because physics was my favorite subject in school. I decided to inspire children all over Bulgaria, and I was really focused on space in my social media accounts. I really wanted to have a good influence on my followers and my friends. And it doesn't matter what is your dream, just follow your dream, whatever it is. And I found out about camps and trainings that, I really wanted to attend or go to. I went to different events, museums, planetariums, and I wanted to learn as much as I could, just because, you have to be prepared for space. My dream became a reality. I flew to Huntsville, Alabama. I changed 3 planes, and I was very scared actually, but it was an amazing experience, and I was shaking. I didn't know that I could make it. I worked on this for a year. So in this picture, I'm just going through the checklist, and I'm also working with a machine for nitrogen and oxygen and hydrogen. You can see some of the pictures that my friends took of me while I was attending the Advanced Space Academy in Huntsville. Hydroponics, mission control inside the International Space Station, posing in front of the Mars base, repairing a rover, and having fun on the zipline. For 2019, I also attended a 16-day long summer school of astrophysics and astronomy, and I was part of the research team of the meteor showers. And I'm really happy to announce that we almost proved the existence of the new meteor shower with the radiant point in the constellation Cygnus. Basically, we observed the night sky from 9 p.m. to, let's say, 4 a.m. It depended on the phases of the moon and, the visibility of the stars. I competed in robotics, and in 2018 my team and I went to the nationals. So basically I worked on a special project about the red planet, Mars. Now, if you want to become an astronaut, you're required to be a scuba diver and have your diving license, or a private pilot's license, or be a military pilot. That's why I dived in the Black Sea last year, and I really enjoyed it. I really hope to continue my training this year. I was also a trainer at the International Science Camp in Plovdiv, Bulgaria. 2020 prevented me from doing a lot of things, but I can say that 2019 was an extremely successful year, at least for me. And I had a conference. I was part of a conference with our first Bulgarian cosmonaut, Ivanova, and 2 Russian cosmonauts, Sergei Zelotin and Alexander Vozutkin. I was invited to attend an official dinner with them. As I said, my mission is to inspire, and I was invited to attend numerous schools all over Bulgaria, all over the country. I met with amazing people, amazing children that had lists with questions about space, about the astronaut selection process, and I was very happy and curious to see what they had for me. In 2020, Georgi Katsarov, a boy from Plovdiv, and I wrote a letter to the president of Bulgaria. We really wanted to be heard. In this letter, we share our worries about Bulgaria, just because we're not a full member of the European Space Agency, which is a big drawback for our country. As I said, my ultimate life goal is to become the first Bulgarian woman in space. We have 2 cosmonauts, Georgi Ivanov and Alexander Alexandrov, but we have never sent a woman from Bulgaria to space. Thank you so much. Thanks to the organizers of this event. If you have any questions, you can contact me. Here's my email, and also you can find me as Astrochita on every social media.
I am Akshat Mohite, astronaut in training with International Institute of Astronautical Science and the president of National Space Society, USA Mumbai chapter. Like, firstly, we'll be talking on the vision and mission of NASA, specifically Johnson Space Center, because that is a center which deals with astronaut training and purposes. Next, we move on to astronaut training and mentality, the skills which you need to become an astronaut. And lastly, we go on to basic presentation on my project, Project Awesome, where I'm a scientist astronaut candidate, and a few things related to hypoxia and G-force training and stuff. So, without wasting any time, let's begin. And I hope I'm audible. So, if I am, just type in yes in the chat. Okay, I assume that I'm audible. So, firstly, let's begin with the vision and mission of NASA. So, talking about the mission of NASA in astronaut training, mostly Johnson Space Center is the one which deals with astronauts, even if you're selected as an ASCAN. So, I am an ASCAN, what that means an astronaut candidate. So, even if you're selected by an ASCAN, you receive a call from Johnson Space Center, and they're like, you're selected to become an astronaut candidate, and to become a full-time astronaut, you need to undergo a few training. So, talking about the mission, we NASA has always been developing new technologies to fly up in space. So after STS, we are just behind other developing technologies. Then SpaceX is one which is also behind this. Next comes the Crew Exploration Vehicle, which took place of shuttle program. Then the ISS, we've been continually behind upgrading ISS, adding new modules to it, like the Soyuz capsule and stuff. So this is a picture wherein you can actually see the Artemis program on the bottom left photograph, and there's the Sunflower Telescope, which you can see. So basically, we are developing a balanced overall program of science exploration and aeronautic consistency with redirection of human spaceflight program. And as we all know, like NASA has been really great in human spaceflight program, as they were the first one to step on the moon, and now they're heading back to moon. The next mission is establishing a lunar return program that we call the mission Artemis, having maximum possible utility for later missions to Mars and beyond. So on the right photograph, you can see the orbit insertion, and above that you have a sample collection on Mars. Then you can see the moon with the satellite, and below it is the Artemis photograph, which was picturized by a 14-year-old guy in America. Education programs. NASA has always been developing new educational programs and grants for students, which is the reason they develop around $250 million every year to motivate students to teach them about aerospace industry and giving them internships and a lot of things. But mostly those are limited to US citizens. But if you're not a US citizen, there are still opportunities that are available for you, about which I'll talk in the later slide. Then comes the educator astronaut program. So selected applicants become a fully qualified permanent member of NASA Astronaut Corps. So it's basically you share your ideas on the next generation explorers, and if you're really successful in creating a revolutionary idea, you get to train as an astronaut, and you can be a full-time astronaut as well. Then comes the education program. Like I said, there are a few programs which you can apply for even without being a US citizen. For example, Space Settlement Design Competition. So when I stepped into aerospace industry, my first project was the Space Settlement Design Competition. And yeah, of course, it was in 2018 mostly. And yeah, I had won it. Next comes NASA Explorer School, which is limited to US citizens. Then the Digital Learning Network. You have many resources available on NASA.gov, which you can use to learn. Then the Texas Aerospace Scholars Program, you can apply for it, and the Jason Project. out of which maybe three were limited to US citizens, but the others were open to all. For more resources on what we say on educational resources or opportunities, if you want to check, you can just go on nasa.gov and you'll find the correct information that you want. Now coming on to the next presentation that we have, that is on astronaut training. So what do you mean by astronaut training? So I'm, I've listed down around 4 points on astronaut training, but there are around 138 tests and trainings that you need to undergo, out of which these four are for full-time astronauts once they have qualified as an astronaut. For example, the Space Vehicle Mock-up Facility. We have one Space Vehicle Mock-up Facility in Johnson Space Center. It is just to give a feel to the astronauts that how will they be behaving, or what's the the map, the layout of the spacecraft they'll be in. So there's a life-size spacecraft in Johnson Space Center wherein these astronauts just wear their spacesuits or their flight suits, like the one I'm wearing right now, wear their flight suits and roam around in the space vehicle, like of course the mock-up of the space vehicle. Then next comes the KC-135. KC-135 is actually an aircraft that is known as Weightless Wonder Vomit Comet. So why do we use KC-135 is mostly to simulate anti-gravity, like microgravity, for like 20 to 25 seconds to train the astronauts the movements in microgravity. We also carry out some microgravity experiments and campaigns for microbiology and stuff, but then mostly KC-135 is used for astronauts to train to learn the motion in microgravity. The next comes the precision air bearing floor. Um, After reading out this point, I actually remember of a story when I had met like an astronaut, Winston Scott, who used to hold the time, what do we say, who used to hold a record for longest spacewalk. He once told me about the how did precision airbearing floor help him. It's like he had gone to space for a satellite insertion, and the satellite was actually inserted wrongly, and it went around 100 meters above the desired location. So what Winston Scott did is he actually went outside into the space, doing a spacewalk, absolutely, and catching hold of the satellite and bringing it down. So that's the reason we do this. It's like one part of an astronaut's work, maybe including like moving large objects, and I mean really large objects sized like a building or something in space. Then comes the neutral buoyancy laboratory. So again, this is like a swimming pool. I would say this is like a swimming pool in Johnson Space Center, maybe like 64 meters of depth. So this is to practice extravehicular activities or spacewalks. Like astronauts go underwater, they do their spacewalks, and there's a simulated International Space Station where these astronauts can actually repair stuff, use the few instruments, and many more. So it's just to learn how to move up there while deep space exploration. Once you're trained as an astronaut, it's there's a really low possibility that you actually go to space even after you're selected as an astronaut. So what you do is you work from the ground, like you work on Earth on simulations like Mars simulation, Hera, like MDRS, Mars Desert Research Station. So what we do here, I have recently applied to MDRS, wherein we just go and there are a few centers like the biology center, the botany center, the extravehicular activity center, and of course the pod for us to live in. So as you can see in the second picture on top right, so that's the building wherein we actually stay, and right side to it is the botany center wherein you actually learn how could you try to farm on Mars. So you actually simulate the conditions on Mars, and then you try to cultivate plants or anything up there. And then of course we do spacewalks and stuff. So these simulations actually are real-time simulations. So like Mars and Earth has a transmission delay of around 15 minutes, like approximately 15 minutes, of course. So once you send a message from the MDRS station to Jet Propulsion Laboratory or Ames Research Center, they maintain the 15 minutes of transmission delay and you'll get the answer 15 minutes later. So that's how we try to maintain exactly the same condition as those would be on Mars. Then I would come to like five skills required to be an astronaut: communication, self-care, leadership, followership, team care, group living. So of course, communication. It's like before doing an action, you need to communicate what's your action. You need to discuss over the action so that all the team members know about it. Second comes self-care. Self-care means taking proper rest, working on perfect timings, and not overexerting, because astronaut is all about self-care. They need to take their care. Then comes leadership or followership. This is one of the most important points. So if you're like a captain or commander of the spaceship, you need to lead your teammates, or if you're a part of team, you need to follow the rules and regulations and the instructions given to you. Team care. Team care is like you need to respect each other's positions, responsibilities, and act as a family. And that's what is actually group living as well. Like you don't grow up together like friends, but then you need to behave like you guys know each other since long, because you're gonna be up there in space, stranded all alone in a group of three, and it's only you. So you need to have really great communication and group living skills. So once I'm, done with this thing, I'd rather go to a basic presentation. As we have kept this seminar for 30 minutes, so I'd like to quickly go through this. So the basic question which I receive like most of the time is like how to get into NASA or any other space agency. So there's no kind of hack or like just shortcut to get into NASA or ISRO or European Space Agency. We require these five things to get into this specific space organization. The most important is the citizenship. So if you're a citizen of India, you can apply for ISRO. If you're an American citizen, you can join NASA. If you're an European citizen, you can join ESA, and likewise. Next comes qualifications. Of course, like many times people just mail me regarding what course should I take up, or like what should I study, where should I study to become an astronaut. So I would just recommend one thing: if you're a bachelor student, take up mechanical engineering or aerospace engineering if you can. Um, and if you're a master's student, then rather just go for astronautical engineering or aeronautical engineering, and that's how you'll be perfectly qualified to get in as an astronaut. Researchers. So what do I mean by researchers is you need to have research papers published. Like today, my age is 18, but like I have around seven research papers published and two patents on my name. So that's how you actually work out to get your name above. Like you want to fly with eagles and not with a pigeon. So you need to have something unique in yourself. Then comes creative thinking. By this point, I actually mean like space is a lot undiscovered. So you need to think creatively. So that way you can actually find out something which is not yet discovered and write up a research paper over it, prove it, and yeah, you're done. And lastly comes critical problem solving. So this, firstly, when I used to present this presentation, I used to just have like 4 points. But when I spoke with astronaut Winston Scott, he told me to add in the fifth point, that is critical problem solving. So, like the story I told you about the satellite, which was um, wrongly inserted into some other orbit, and he had to pull the satellite down to the desired location. So it was all related to critical problem solving on basic instances. Coming on to Project Possum, the first mission I entered in as a scientist astronaut candidate, Project Possum. So what does Possum means? Possum is basically polar suborbital science in upper mesosphere. This might sound a lot technical, I know. Basically, this is a mission wherein we study the mesosphere and do noctilucent cloud tomography. So, what is tomography? Tomography is basically clicking pictures and photographs of a certain type of cloud, which we call noctilucent clouds, because they're really white in color and you can't see through. So, this is mostly important in re-entry of space vehicles. So, if your space vehicle is entering back into the atmosphere of Earth, and once it's in the mesosphere, you can't actually have a look or have a view at the spacecraft when it is near the noctilucent clouds, and that's what we do. We go up there, like, of course, we don't touch the mesosphere with those normal kind of jets, but then we try to attain such heights that we can actually use the red cam and click pictures of mesosphere and study how these are created and how can the problem be tackled. So that's basically my mission. This is the mission patch. It's written Boston. So yeah, then comes hypoxia. To be an astronaut, there are not only four tests that you need to give. Like I told, there are more than 100 tests that you need to pass, and hypoxia is one of them. So in hypoxia, you're actually put inside a chamber, a pressurized chamber, and it takes you at an altitude of 25,000 feet, of course, by altering the pressure inside the chamber, and it checks the oxygen supply in your body. And in the right picture, in the second picture, you can see my certification of SAMI, which certifies me, for my hypoxia training and aviation psych physiology training. The hypoxia is a condition in which body or a region of the body is deprived of adequate oxygen supply at tissue level at an altitude of 25,000 feet or above. So my oxygen level at 20,000 or 25,000 feet was like 91%, which was really, really good. And that's the reason I got this license from SAMI. Now, this slide shows my G-force training. So I personally have taken up to 6Gs. It's not visible on the sheet, but then I'll show you one video once I'm done with this. So I personally have taken around 6Gs of force, and this is what you get once you're in flight. A single piece of paper inside an envelope, and once you're up in the sky, you just open this paper and you see what are the manuals that you need to do. Like you need to make a 360-degree turn to the right, then a 360-degree turn to the left, at 2Gs, and the same at 3Gs. Then you reach around 4G, like a total 360 turn, and then you go into microgravity, and again the same, and then you go to GY and negative G. Okay, so it sounds pretty much technical, but then if there are a few aerospace engineers out there, they might be pretty much well versed with this kind of aviation diagram. Okay, then, any questions, just hit me up on the email ID, and you can follow me on Instagram. My Instagram ID is Cosmo Akshat, COSMOAKSHAT, and I'm open to questions. So, any questions, just hit me up. Thank you very much. Stay home, stay safe.
Search for life beyond Earth and Mars. Before I introduce myself, first let me ask you a question. Why are we just focused on Mars and Earth for life? There are other celestial bodies, there are other planets in our solar system, and beyond it, why don't we search for life there? So, hello everyone, this is Deepika. I'm senior high school student currently, and I'm a citizen scientist researcher and aspiring astronaut and vice representative of Space Magica. So my next question to you is, what comes in your mind when you just look in the sky at the night time and think of your existence? What makes you wonder? So let's get started. So, are we alone in this universe? This age-old question is yielding some provocative new answers. Recent discoveries suggest that the condition for life must be more prevalent than ever imagined. The zone where life could possibly exist has expanded out from Earth to the outer reaches of the solar system and places where jets erupt hundreds of miles into the space. Tens of billions of planets are estimated to be orbiting other stars in our own galaxy alone. Could there be an Earth-like planet among them? This is the biggest question we humans have right now. For sure, we will find habitable worlds, if not this week, then next month, then next year, sooner or later. So, now for life to exist, search focuses on three key ingredients. The first one is life's basic chemical building blocks, made from simple chemical elements found in the cloud of gas and dust that gave birth to all of the planets and moons. These chemicals were possibly delivered throughout the solar system billions of years ago by comets and asteroids. They are compounds called organic compounds, containing carbon, oxygen, hydrogen, and nitrogen. Next comes life needs liquid water. Not liquid water, liquid like water, that allows these compounds to mix and interact. And finally, an energy source like the sun to power the chemical reactions that make life possible. Scientists once believed that these three ingredients could only be found, if at all, on all planets that are just at the right distance from the sun. If it is too close, then it's too hot, and if it's too far, then it's too cold to live. So here you can see in the image the habitable zone in which they believed life must exist anywhere. But now the problem is that missions to the outer solar systems are calling these assumptions into questions. Here you can see Jupiter, as seen by space probe Voyager 1, launched decades ago to explore the outer solar system. 500 million miles from the sun, it seems unlikely that life could exist out here in such extreme cold. But when Voyager approaches Io, which is Jupiter's moon, it found that Io should be a frozen, icy, barren world. But Voyager spotted something completely unexpected. These actual images of Io's surface reveal hundreds of active volcanoes, and later probes exposed vast lakes of molten lava too. It's like that on Earth, volcanic activity is driven by heat in the interior, but Io is so small that it should have cooled down billions of years ago only. So what was that heating it up? So again, to find out that answer, we went ahead, and so we thought that there must be another source of energy inside the moon. By observing Earth's volcanoes and studying the huge amount of data gathered from inside the moon, Io scientists concluded that either it is very very cold or it is very very hot, where there are more connected activities taking place. And of course, there is no atmosphere, and there would be a bounce in your step because the gravity of Io is same as the moon of our Earth, that is 1/6 of Earth. Now again, the question is, what could be generating so much energy in a moon that should be a frozen solid, and what is the power coming from? So scientists found that the key to understanding these volcanic activities is its own planet, that is planet Jupiter. Io orbits Jupiter in a slight ellipse rather than a circle. So here you can see in the images, the blue figure represents an ellipse and the one in green represents a circle. So the logic behind is that With every orbit, Io experiences gravitational pushes and pulls from Jupiter and other moons. When Io is closest to the Sun, giant planet that is when when Io is closest to the Jupiter, it is stretched by more than 330 feet. Over billions of years, this has created a large amount of friction deep inside the world. This continuous flexing of the satellite is like bending a piece of metal that heats up. So, this is the ultimate source of Io's volcanic energy and its volcanic heat. So, the powerful tidal force generated by the massive gravitational pull of Jupiter creates an alternative source of energy far from the warmth of the Sun. Now, what's so important about Io is that it removes our perception away from a habitable zone, which we saw in the last slides, that a habitable zone should lie at the right distance from the Sun, because Io is not in that right distance. I hope you understand. So, the chances of life existing on Io itself are less, I believe, but even though it has an energy source and could have right chemical building blocks which were possibly delivered by comets and asteroids billions of years ago. Because scientists have not yet detected the third key ingredient, that is liquid water, so we can't say that life exactly exists there, but yeah, we can hope for it. So, coming up to the next moon, that is Europa, which is quite famous among all of us. NASA's unmanned space probe Galileo flew by Europa. It passed by Europa 12 times. Europa is covered with ice. We all know that. Data collected by Galileo shows that surface is minus 260 degrees Fahrenheit, which is surely very harsh to life. We can't live there. But as the probe went closer to it, it took these images, which are shown here. A mysterious network of dark cracks was found into Europa's icy surface. In addition to the dark cracks, the probe also revealed vast jagged areas of ice that appear to have melted, broken apart, and frozen back together again. These images showed that there is something very dramatic happening to destroy the existing surface. After observing these images for a while, they concluded that it's familiar pattern. Like these cracks and rags things were seen on Earth earlier too. So scientists wondered that where they have seen that. So they found that sea ice found on Earth looks very similar. They said that it was very hard to get that pattern without having an ocean underneath the ice. So later on, the magnetic field data suggested that miles down Europa's icy surface, there is an ocean that could be 60 miles deep. It was really amazing to find out that this small moon could have as twice much water liquid, and as it was present on our own Earth. So it means that if you live there, then your country's government is not going to punish you for wastage of water, because it already has lot of water. So coming up to the point, scientists try to find out that reason behind it, that why it has such conditions, what they saw. They said that something must be melting the moon from deep inside. And again, the key is Jupiter, the same gravitational force that flexed Io's rocky interior, turning it into an ocean which was concealed beneath miles of ice, and where even there is no energy from the sun. To find it out that when there is no energy from sun, and that the third key ingredient focuses on the an energy source, but when there is no energy source, then how could life possibly exist there? So a scientist, that is a biologist, explored the oceans here on Earth that most resemble Europa's icy depths. He sent robots to search for life 12,000 feet beneath the Arctic ice sheets, where sunlight never reaches. And these conditions are just similar to Europa's conditions. So he just tried to search for that. He found that volcanic activities were pushing apart the sea floor. Scientists believe that something similar may be at work under the ocean on Europa. They believe it has rocky core, and that rocky core is under the title of forces and influences just as the rest of the planet does. So his robots discovered evidence of an extremely hostile environment. His team found new forms of life indirectly through microbes that covers miles of seafloor there. Now again, science is full of questions, and now it's very clear that basic elements that we need for life are on Europa, and the necessary chemical building blocks are also there, perhaps delivered by comets and asteroids, according to the theories that we study. Then there is nothing that we can think of, no component that's missing from an open ocean. That is, since all the three key components of life are found here, about which I told you in the very beginning of the presentation, it is nearly fully possible that life exists here. And that is really amazing news for us, because maybe we have found our second home. Again, science is full of problems and questions. So the next problem is that getting a probe safely to the surface of Europa to test these theories, and these theories is just one of the challenges in looking for life 500 million miles away. Like, we need to build something that can get through what is surely kilometers of ice, and that's hard to do on Earth. We can't we have not built such a machine yet. So, and next we will have to have something that can swim too, because it has lot of water. So for that, just everyone was confused at how to do these things. Then this man, whom everybody knows, Elon Musk, he promised that his mission to Europa can safely land even humans on Europa. Isn't it so amazing? Like, everybody is just thinking of just landing a probe on that celestial body, and he is promising that he can land a human too. So the conclusion about Europa is that it isn't the only place this far out. In the solar system, maybe similar conditions exist on other moons orbiting other planets even further away from the sun. So coming up to the next slide, one mission launched to find out is probe Cassini. Now we have end up with Europa and we move up to Cassini. Cassini was heading for the ring planet Saturn, 1 billion miles from Sun. Its mission was to explore Saturn and find out how its vast rings formed and investigate some of the more than 60 moons. Yeah, Saturn has more than 60 moons. So Cassini was outfitted with most sophisticated system of scientific instruments ever carried out in our solar system. It has cameras and spectrometers, as you can see in the image. 7 years after launch, Cassini finally entered into orbit around Saturn. These images reveal the rings in detail. As you can see, they stretch out across hundreds of thousands of miles, but in some places they are just 10 feet thick. So it's quite uneven to measure the rings of Saturn. So Cassini confirmed that these majestic rings are made of billions of shining particles of almost pure water and ice. They range in from size of a grain to a mountain and dust. Yeah. Then, after nearly 8 months of collecting data, Cassini reached to Saturn's closer moon, like one of the closer moons, and it was called Enceladus. So here you can see that. Yeah. These Cassini images reveal a shining white surface unlike any of other Saturn's moons. It is carved with ridges and cracks as shown in these images. Cassini photographs these strange large cracks. Scientists named these images by Cassini the tiger stripes because they look alike tiger stripes. They are 75 miles long and hundreds of feet deep. And yeah, so Enceladus was a major focus for Cassini mission because they found something interesting there. It was very clear that there had been something going on in Enceladus in the past. But again, the question is, as science is full of questions, that is there anything going on in the present? Like we all know that every celestial bodies faced some or the other thing in the past, but what makes them special is that is there something going on at present on them? So moving on, later Cassini's thermal imaging sensors revealed something unexpected. At the south pole of Enceladus, the tiger stripes should be colder than the rest of the moon, but they were radiating heat, and that was quite amazing because the place which should be cold, it was radiating heat, and it was just blasting the minds of scientists. So then as Cassini changes its orientation, it saw vast jets of ice erupting into space. The second image here shows it. These images reveal the jets are blasting hundreds of miles out from the tiger stripes, as you can see here. Now the next comes the energy source for life to exist there. Like we are just in this whole presentation, we are searching for those three key ingredients which are necessary for life to exist on any celestial body. So was it possible that Enceladus also have an internal energy source like Io and Europa? Because we already saw it in two cases earlier. So scientists believe that when Enceladus orbits the massive Saturn, friction from gravitational forces causes it to heat up melting ice in the moon's interior, the same way as on Europa, which I told you just just now. So excited by this discovery, the team programmed Cassini to fly through the jets, because those jets were the thing which could reveal many things about it. So after several fly-throughs, Cassini spectrometers detect in the jets some of the basic chemical buildings of life that was some of the basic chemical building blocks of life that was even more exciting to find, because not only do we think there's liquid water, there's a huge amount of excess heat and also organic materials. What does that mean? Yeah, exactly. It is totally possible that life exists there because we found all the three key ingredients for life there. So yeah, again you can say that we have possibly find our second home. But the problem is, since Cassini didn't detect any signatures of life itself, so there is no evidence yet that microscopic organism in these jets exist. But the exciting thing is that this discovery makes Enceladus a prime candidate for future missions, and we can look for life here by our future missions and yeah. So what did we do till now? That we found that missions to extreme environments are showing that microbes can live in extreme conditions. Hence, we need to put more effort to search for life even at unexpected places. Yeah, it is. We need to put more effort because we saw that scientists believe that habitable planet or celestial body should lie in a habitable zone, but it was proved wrong, and then we saw these things. So yeah, we need to enhance our thinking ability. So could environments on other worlds which we previously thought too harsh for life be worth a second look? It's a question, and the answer is yeah, definitely. We really need to push ourselves out there in the terms of thinking what the possibilities are, as I said. So moving ahead, could environments on other worlds which we previously thought too harsh for life be worth a second look? Yeah, definitely. We really need to push ourselves in terms of thinking what the possibilities are. So moving on, So further, scientists wanted to know if life could develop in new ways, perhaps using new chemical building blocks and new chemistry. So they moved on and they found that one such place is one of Saturn's moons visited by a space probe Cassini called Titan. Again, it's a famous moon we all know of. Cassini detected organic building blocks in the atmosphere, and the spacecraft's radar revealed something mysterious in the clouds. Under the clouds of South Pole, it looked like a lake of water. Yeah, so it was found that this liquid was at minus 290 degrees, and this liquid couldn't be water, because we all know that water freezes at a certain temperature and it's not minus 290 degrees. So it was not water. So what was that? Then analysis of infrared light revealed that they are filled with liquid methane and ethane. These hydrocarbons gases are used as fuels here on Earth. So data now shows that methane on Titan flows in river valleys, forms clouds, and even falls as rain, just as liquid does on Earth. So we can say that we have liquid water and Titan has liquid methane and ethane. So it's quite similar. So, but again the question was, could it act the way water does, an essential foundation for life on Earth? Because if we are comparing liquid water and liquid methane and ethane, then we should compare life also. Then the organic building blocks that Cassini's instrument detected high in Titan atmosphere stimulates an energy source. We know that there are conditions that maintain liquid, there is an energy source, and there is organic material. Also there are nutrients, there is an environment, so that may be suitable for life. But if there is life, then it's going to be completely different than anything we have on Earth for sure. It is very common thing that if we are comparing life to liquid methane and ethane, then we should compare the different form of life on Earth to different form of life on Titan too, which we hope for is there. So there are many other telescopes. We have concluded Titan, and moving on, we say that there are many other telescopes searching for life in the cosmos. Few of them are shown here. But before moving there, the main question is that even if we find a world just at the right distance and of right size with oceans of liquid water, could we detect life from trillions of miles away from here on Earth? The answer is definitely yes. We are on path to do that, because nobody imagined that we can land humans on moon and we can land on Mars few years back, but it is possible, so it can be possible too. So moving on to telescopes, the James Webb telescope shown here may be able to do that. This new telescope is 3 times more powerful than Hubble, which is shown here. It will be able to analyze starlight passing through the atmosphere of the closest Earth-like worlds. The other one is Kepler telescope. This space telescope has a mission to focus on one tiny spot of space and scrutinize 150,000 stars of sign of planet. So Kepler is already producing mountains of data, we all know that, and has already discovered a few planets that have a diameter and a mass that indicates clearly the planet is rocky according to planetary science. So moving on to conclusion, many believe that this is a turning point in history when we at last have the technology and the know how to find out if there is a life life beyond Earth and possible beyond Earth. So I would suggest that a lovely exercise for you to do is to look up into the night sky, look at the twinkling stars, and realize that those stars by and large all have planets, just as our star, that is sun. Just like our own galaxy, there are hundreds of billions of galaxies out there, and so there are uncountable number of planets in the universe. So thank you to everybody, and I congratulate you everyone for having such a big dream and working hard for it. So lift off.
The universe has given us the beautiful wings to fly, the deep space and the skies to get involved into our own deep thoughts, and the stars and the moons to make us believe in the beauty of our dreams. Hello everyone. I am Smiriti Srivastava from India, a student, a space enthusiast, and an aspiring astronaut. I am a member of the Space Magica and the International Organization of Aspiring Astronauts. First of all, I would like to thank the Space Magica and the International Organization of Aspiring Astronauts for giving me this opportunity to address the Aspiring Astronauts Conference. So today, I would like to talk upon the topic space weather and exploration. So starting with my presentation, the video shows the picture of the sunset and the sunrise. Our star, the sun, which appears to be so constant and gives us the beautiful new views of nature. But is it so as it appears? The video shows the picture of the sunset and the sunrise. Our star, the sun, is a constantly violent raging star and spurts out the plasma from its surface in the form of the energetic charged particles and has the sound something like that of the deafening church bells. The plasma and the charged particles interact with the magnetic field of the planet. For example, you can see over here for Earth. Leads to the weather conditions on a space termed as the space weather, which can interfere with the communication satellites, GPS navigation, and poses dangerous threats to the life of astronauts. The dark patches which you can see over here on the solar surface, which are comparatively cooler than the other regions of the sun, are the sunspots and are the main cause behind the space weather phenomena. The sunspots occur in the pair and release very strong magnetic field and can be visualized similar to that of the magnetic field of a bar magnet. Here, this picture shows the close resolution. These sudden brightenings which you can see here on the solar surface are the solar flares, which occurs during the time when the solar activities are on a very high scale. These solar flares can trigger the coronal mass ejections. Here, this is a picture of the coronal mass ejection as viewed from a coronagraph. The stream of the charged particle emanates continuously from the sun and consists of the suprathermal particles, which blows out to the interstellar medium as the solar wind and creates a bubble known as the heliosphere in the stellar medium and thus protects us from the galactic cosmic rays. The solar winds from the sun interact with the magnetic field of the earth, thereby producing geomagnetic storms on the earth. The solar storms arise from the sun and reach out to the planets. In about 4 to 5 hours, it blows past the Mercury, then Venus in 12 hours and reach the Earth after 15 to 18 hours. When the solar storm reaches the Earth, it is deflected by the shield of the Earth's magnetic field termed as a magnetosphere, and the magnetic reconnection phenomena occurs. Here, the sun and the earth magnetic field interact and the twisting of the magnetic field causes the solar storm to stretch towards the earth's magnetotail, and the charged particle in the solar storms interacts with the gases and the particles in the upper atmosphere of the earth, thus leading to the production of the aurora borealis or the aurora australis. The sun goes through the different phases of the solar activities and follows a time period of 11 years. Every 11 years, the magnetic field of the sun flips and the north and the south pole switches their places, leading to the solar minimum and the solar maximum. During the solar minima, the activity activities of the sun drops to very low and there are very less sunspots. But the solar maximum witness increase in the number of sunspots and the solar activities. Here, the graph shows the variation in the number of sunspots during a particular solar cycle. The previous 4 cycles have continuously seen a declining trend in the decrease of the solar activities. And the solar cycle 25, which is started in late 2020, holds a lot of debate as to what it will lead us to, with its maximum predicted to occur in 2025.